Hello everyone, and welcome to Earth Archives. Today, we're not going to talk about other planets, but about the big star that accompanies us every day, the Sun. I've always thought the Sun was just that bright round ball in the sky, but I heard it actually has an incredible story.
The Sun is much more than just the big light bulb we see every day. It has a magnificent history spanning over 4.6 billion years. It's a star that continuously burns, generating endless energy through nuclear fusion, powering life and motion throughout the entire solar system. During this fusion process, the Sun fuses hydrogen atoms into helium atoms, releasing enormous heat and light radiation. This not only lights up our planet, but also brings warmth and the possibility of life. Even more amazing, the Sun is the core manager of the solar system. Its powerful gravity firmly controls the orbits of all the planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, as well as countless asteroids and comets, all orbiting it in an orderly fashion. Without the Sun's gravitational pull, this intricate cosmic system could not be maintained, and the planets would not remain stable. The Sun's surface temperature reaches about 5,500 degrees Celsius, and its core temperature is an astonishing 15 million degrees Celsius. This extreme environment creates the miracle of nuclear fusion. The light and heat it constantly emits make Earth a beautiful planet suitable for life, while also shaping our climate and seasonal changes.
Wow, so the Sun is like a cosmic power plant? How was it born?
About 4.6 billion years ago, the universe was still chaotic, and that's when the Sun's story began. Back then, there was a massive solar nebula in space, made mostly of hydrogen and helium gases, mixed with countless tiny cosmic dust particles. Under the force of gravity, these gases and dust gradually clumped together, forming a denser and denser cloud. As more material gathered toward the center, the pressure and temperature in the core kept rising, eventually reaching an astonishing 15 million degrees Celsius. In this extreme environment of intense heat and pressure, hydrogen atoms started to undergo nuclear fusion, the process of hydrogen nuclei merging to form helium nuclei, releasing an enormous amount of energy. This energy was enough to counteract gravity's pull, stabilizing the core. At that moment, the Sun officially ignited and became a true star. Since then, it has continuously shone and radiated heat powered by nuclear fusion, becoming the central manager of the solar system, controlling the orbits of the planets. This birth process not only symbolizes the vitality of the universe, but also reveals the fundamental reason our planet exists.
Oh my gosh, sounds like a massive explosion. Is the Sun still bubbling and burning inside right now?
The Sun, this gigantic fireball in the universe, is performing an incredible nuclear fusion miracle every second. It converts about 600 million tons of hydrogen into helium every second through fusion, releasing an enormous amount of energy. This energy is the life source of the entire solar system, driving photosynthesis on Earth, climate cycles, and maintaining the basic conditions for all life. However, this energy's journey isn't instantaneous. When hydrogen fuses in the Sun's core, the photons, particles of light, produced are repeatedly absorbed and re-emitted by the dense solar material, wandering through a kind of maze inside the Sun. It takes tens of thousands to hundreds of thousands of years for this energy to gradually travel from the Sun's core to its surface. This long wait is what allows the Sun's surface to continuously emit a steady and bright light. Once these photons reach the Sun's surface, they shoot out into space at the speed of light. Amazingly, the distance from the Sun's surface to Earth is about 150 million kilometers, and photons take only about 8 minutes and 20 seconds to reach us. This brief journey lets us constantly feel the Sun's endless warmth and light, serving as the priceless energy source that fuels life's thriving on Earth.
Wow! So the sunlight I'm feeling now is actually energy that was born tens of thousands of years ago?
Exactly. Every ray of sunlight on you carries an incredible cosmic time journey. These photons were born in the sun's core and spent tens of thousands, even hundreds of thousands of years wandering through the hot, dense interior of the sun before finally bursting forth as the bright light you see. This means that when you bask in sunlight, feeling its warmth and brightness, you're actually touching a cosmic journey spanning thousands of centuries. Imagine this. That light, which seems to arrive instantly, has actually been on a long adventure inside the sun, passing through countless layers of plasma, dodging collisions with atoms, until it finally breaks through the surface and shoots straight toward Earth. It's a miracle crossing time and space, reminding us of the vastness and intricacy of the universe's workings. When those photons race from the sun's surface to Earth, it only takes about 8 minutes and 20 seconds. A journey at the speed of light that seems instantaneous. But the entire process before that moment has taken eons. This energy conversion spanning billions of years not only sustains Earth's ecological balance, but also serves as an indispensable source of energy in our daily lives.
So romantic. What does the sun actually look like? Is it really like a giant fireball?
Although the sun looks like a bright sphere, it's not solid. It's a massive, blazing ball of plasma, which is a special state of matter made up of charged particles. The sun has a clearly layered internal structure, with each layer playing an indispensable role, interacting with the others to sustain the life source of the entire solar system. The core of the sun is basically a nuclear fusion factory in the universe, where hydrogen atoms fuse into helium under extreme pressure and temperature, releasing incredible amounts of energy. The core temperature reaches about 15 million degrees Celsius, and this is where the sun's energy production begins. The energy doesn't burst out directly from the core. Instead, it slowly travels through the outer layers, the radiative zone and the convective zone, in a delicate, gradual process. Photons in the radiative zone are absorbed and re-emitted countless times as they slowly move outward from the core, a process that can take tens of thousands of years. Then, in the convective zone, gases move in strong convection currents due to temperature differences, carrying heat to the surface, which is also the source of much of the sun's surface activity. What we see with our naked eyes is the sun's surface called the photosphere, with a temperature around 5,500 degrees Celsius. The photosphere emits dazzling light and heat that illuminate and warm the entire solar system. Interestingly, the sun's outermost layer, the corona, has temperatures reaching millions of degrees, far hotter than the photosphere's surface. This temperature inversion remains one of astronomy's greatest mysteries.
Wait, the outer layer is hotter than the inner layers? That doesn't make sense.
The sun's corona reaches temperatures of millions of degrees, far hotter than the surface photosphere. This phenomenon remains one of the greatest mysteries in astronomy. Why is the corona so hot? This question not only challenges scientists' understanding, but also drives our quest to unravel the secrets of the universe. Currently, scientists widely believe that the heating of the corona is closely related to the sun's powerful magnetic fields and plasma waves. The complex, interwoven magnetic field lines inside the sun and its atmosphere act like invisible threads, weaving through the entire solar system's dynamics. These magnetic fields constantly twist and rearrange, releasing huge amounts of energy, which may be the key to heating the corona. Similarly, high-speed plasma waves vibrating in the solar atmosphere might carry energy from the core all the way to the outer layers, causing the corona's extreme temperatures. Although these theories offer possible explanations, many questions remain about how the corona goes from cool to hot. In recent years, scientists have used satellites and space telescopes, such as the Parker Solar Probe and the Solar Dynamics Observatory, to collect precise data in an ongoing effort to lift this cosmic veil. Each observation could lead to breakthroughs, helping us solve this century-old puzzle.
That's so cool. So the sun also creates some strange phenomena?
The sun isn't just the source of our life. It also puts on a spectacular and wild cosmic show, full of mystery and power. Some of the most iconic events are sunspots, solar flares, and coronal mass ejections, CMEs. These activities are not only the result of changes in the sun's magnetic field, but also directly affect the environment on Earth and throughout the entire solar system. Sunspots are areas on the sun's surface with especially strong magnetic fields. Because of magnetic disturbances, these regions have relatively lower temperatures, so they appear dark, like spots on the sun's skin. Although sunspots themselves are cooler, they often serve as hotspots for solar activity, acting as the starting points for the release of intense magnetic energy. Even more dramatic are solar flares and coronal mass ejections. When the sun's magnetic field undergoes sudden, intense changes, energy bursts out instantly, producing solar flares that release huge amounts of high-energy radiation and particles. Coronal mass ejections are like massive solar storms that hurl charged particles and magnetic field blobs into space at astonishing speeds. If these high-energy particles strike Earth directly, they can disrupt satellite communications, GPS signals, and even affect power grids, potentially causing large-scale blackouts.
Wow! So the aurora is actually the sun's gift of light to us?
Exactly. Although the sun's activity may seem a bit violent from a cosmic perspective, it's actually a magnificent and heartfelt romance. Imagine a star quietly burning for over 4.6 billion years, constantly releasing energy that lights up the entire solar system, warming the Earth, and allowing life to be born and sustained. That persistence and explosive power is the universe's version of tenderness. From sunspots to solar flares and coronal mass ejections, each phenomenon reveals the sun's inner strength. While they may appear wild and can affect Earth's communication systems, satellite operations, and even power grids, it's precisely these events that allow us to witness the miracle of the aurora. Under the polar night sky, the colorful curtains of light dancing above are the sun's most splendid love poems sent to Earth. Behind these solar mood swings is a delicate balance of magnetic fields and energy. Through nuclear fusion, the sun converts hydrogen into helium, producing light and heat that travel through its layers, taking tens of thousands of years to reach the photosphere, and then just 8 minutes and 20 seconds to arrive at Earth, becoming the sunlight we know. Wouldn't you say this is another kind of slow-cooked cosmic affection?
So, will the sun ever burn out one day?
The sun has its own life cycle, and right now, it's in its middle-aged golden period. This star, which has been steadily burning for about 4.6 billion years, is expected to continue providing light and heat to Earth for roughly another 5 billion years. But nothing lasts forever. When the hydrogen fuel in its core gradually runs out, the sun will embark on a magnificent yet tragic final journey. First, as hydrogen becomes scarce, the sun's core will start to contract while its outer layers expand due to energy escaping, turning it into a massive red giant. At that time, its size will be enormous, possibly engulfing Mercury and Venus, and maybe even Earth. Imagine that the sun, which once gave life, could ultimately become Earth's possible end. This is one of the awe-inspiring natural laws of the universe. Next, the instability of the red giant's outer layers will cause it to shed its skin, throwing off its atmosphere layer by layer into space, creating a beautiful and dazzling planetary nebula. These aren't planets. They are called planetary nebulae because they appeared as fuzzy disks through early telescopes from Earth. This stage marks the sun's most spectacular finale, like an old painter pouring all their colors into one last stroke. In the end, only the core remains, a white dwarf, quietly shining like embers in the cosmos. It no longer undergoes nuclear fusion, but will continue to glow with residual heat for billions of years until it finally cools completely.
Oh my gosh! So the Earth might get eaten by the sun?
The sun's ultimate fate sounds spectacular and a bit scary, but don't worry. That cosmic drama is billions of years away, and we're still very far from it. According to astronomers' predictions, the sun will remain stable and keep burning for about another 5 billion years. During that time, it will continue to provide Earth with light and heat, sustaining life as it does now. So, this isn't some disaster happening tomorrow. It's more like a cosmic reminder, giving humanity plenty of time to think about the future. Maybe by the time the sun enters its red giant phase, our technology will have advanced enough for us to live on Mars, moons of Saturn, or even other star systems. Or perhaps artificial intelligence and human consciousness will have merged into a new kind of being that can travel across the universe. Either way, by then, humanity should have entered a whole new stage of civilization. Interestingly, this topic of the sun's future often appears in astronomy textbooks, sci-fi novels, and movie scripts because it reminds us of one core truth. The universe is dynamic and nothing lasts forever. Even the sun above our heads is on its own life journey. We just happen to live in its most stable and gentle era.
Phew, you scared me. Good thing it's not happening tomorrow.
For us humans, the sun is currently in the golden phase of its life, known as the main sequence stage. During this period, the sun steadily undergoes hydrogen fusion, converting hydrogen into helium and continuously releasing light and heat. This steady energy supply creates the warm and habitable environment on Earth, which is crucial for life to evolve, reproduce, and thrive. The sun can maintain this stable state for about 10 billion years, and since it's currently around 4.6 billion years old, it still has more than half of its lifespan ahead. That's why we are living in an incredibly lucky time in cosmic history, a time when the star doesn't run wild, explode, or collapse, but remains warm and steady, just right. This stage is not only the cradle of life on Earth, but also the foundation for Earth's climate system, atmospheric circulation, and plant photosynthesis. Simply put, without this just right temperature from the sun, the world, as we know it, wouldn't exist.
But I often hear people say the sun is way bigger than the Earth. So just how much bigger is it exactly?
It's seriously huge, like beyond what we can really imagine. The sun's diameter is 109 times that of Earth, and its volume can fit a whopping 1.3 million Earths inside. That's right, 1.3 million. Just thinking about that number gives you chills. Even more mind-blowing, its mass is about 330,000 times that of Earth. In fact, 99.86% of the entire solar system's mass is concentrated in the sun alone. That immense weight and gravity is what keeps all the planets obediently orbiting around it. If you want a metaphor, Earth next to the sun is like a tiny sesame seed orbiting a massive supersized furnace, almost unimaginably small. But precisely because the sun is so enormous, it can sustain nuclear fusion for billions of years, steadily releasing light and heat to keep Earth warm and full of energy.
Wow! So we're basically a little planet that lives off the sun.
Exactly. The sun is like the ultimate housekeeper of the universe, holding the entire solar system tightly together with its incredibly powerful gravity. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, these 8 major planets, plus countless asteroids, comets, and dust, all of them orbit around the sun, spinning round and round in a cosmic dance that's lasted billions of years. The sun's mass accounts for 99.86% of the entire solar system. This overwhelming weight creates a strong gravitational pull, like a giant magnet at the center, holding all these celestial bodies in place, organizing and keeping everything perfectly orderly. Without the sun's role as the housekeeper, the whole solar system would have long ago descended into chaos or even collapsed. What's even more amazing is that this housekeeper not only controls the orbits of planets, but also sets the rhythm of the entire solar system. Its magnetic field stretches billions of kilometers outward, creating what we call the solar wind, which blows across the edges of the solar system, affecting Earth's magnetic field and even interacting with cosmic rays.
Does the sun spin by itself?
The sun's rotation is quite special. It's definitely not like a solid ball spinning all at once like we might imagine. Because the sun is mostly made of gas and plasma, it doesn't have a solid surface like Earth. This means different parts of the sun rotate at different speeds, a phenomenon called differential rotation. Specifically, the sun's equator spins the fastest, completing one rotation in about 25 days. Meanwhile, near the poles, the rotation is slower, taking around 35 days to complete a full turn. This uneven rotation makes the sun's magnetic field very complex and dynamic. This differential rotation acts like a constant stirring of the magnetic field lines inside the sun, twisting and tangling them until magnetic explosions occur. These produce phenomena like sunspots, solar flares, and coronal mass ejections. Together, these activities form the sun's approximately 11-year solar cycle, which affects Earth's space weather, communication satellites, and even the creation of auroras.
Wow, the sun really has so many secrets. So, what's its position like in the Milky Way?
Although the sun looks incredibly bright, it's actually just an ordinary star among the hundreds of billions in the Milky Way. It quietly sits in the Orion arm of the galaxy, carrying our entire solar system as it slowly orbits around the galactic center. This journey takes an astonishingly long time, about 250 million years for one full orbit. In other words, since the time dinosaurs appeared until now, the sun has completed just one magnificent trip around the galaxy. This scale of time is mind-blowing and really helps us appreciate the vastness of the universe. Imagine, back in the age of dinosaurs, the sun was steadily guiding the Earth and other planets through the galaxy, and all the stories of life's evolution unfolded during this long voyage. It's a powerful reminder that what seems like a brief life on Earth is actually just a fleeting moment in the grand flow of cosmic history.
Oh my gosh, now this is what I call a real-world tour.
Exactly. At the center of the Milky Way hides a mysterious and powerful giant, the supermassive black hole called Sagittarius A star. This black hole has an astonishing mass about 4 million times that of our Sun, yet it's compressed into a region roughly the size of the Sun itself. Although we can't see it directly, its powerful gravity acts as the Milky Way's invisible engine, keeping countless stars, nebulae, and galactic gas steadily orbiting around it. Sagittarius A**'s existence has unlocked many astronomical mysteries. It not only governs the dynamics at the galaxy's core, but also influences the overall structure and evolution of the entire Milky Way. Imagine the galaxy as a vast cosmic city, and Sagittarius A** is its central engine, controlling the rhythm of everything. The black hole's mystery and invisibility make it a hot topic in space exploration. Modern telescopes and radio interferometers have gradually revealed more details, bringing us ever closer to understanding this heart of the universe.
Wow! So our sun is actually just an ordinary star in the universe?
When we look up at the night sky and see countless twinkling stars, we might think the sun is just one ordinary star among many. However, for life here on Earth, the sun is the most important and indispensable star. Without the sun, Earth would become a cold, dark world where life cannot exist, and the entire ecosystem would collapse. The sun isn't just a glowing ball of heat, it is the source of our life. The sun's light and warmth provide Earth with the temperatures suitable for living organisms, driving water cycles, climate systems, and photosynthesis in plants. Through photosynthesis, plants produce oxygen, supporting the entire food chain, from tiny insects to large animals, all dependent on this chain of life. In other words, the sun provides not just light, but the fundamental energy that sustains all life. Moreover, the sun's stability has created a livable environment on Earth. It has been steadily burning for nearly 4.6 billion years, and will continue to do so for several billion more. This time span is enough for life to evolve from simple single-celled organisms to complex beings like humans. It is this enduring stability that has allowed life on Earth to continue and evolve.
After hearing all this, I really feel the sun is so magnificent. It's not just a source of light and heat, but more like a silent guardian of life in the universe, a star of life.
The sun, though seemingly ordinary, possesses an astonishing dual nature. It is both warm and dangerous, both common and great, like a cosmic guardian and a creator of endless mysteries. The sun's existence not only gives life to Earth, but also inspires humanity's boundless imagination and passion for exploring the universe. From afar, the sun is that bright, shining ball in the sky that brings us light and warmth. Its energy fuels all living things on Earth and stabilizes the climate, fundamental for life to continue. Yet inside, the sun is a scorching, violent nuclear fusion reactor, converting hundreds of millions of tons of hydrogen into helium every second and releasing enormous energy. Sometimes this power erupts in intense solar flares and coronal mass ejections, hurling high-energy particles into space and affecting Earth. This seemingly gentle yet hidden danger makes the sun both a friendly and threatening presence. The sun's greatness also lies in being the central housekeeper of the entire solar system. Its powerful gravity pulls planets, moons, asteroids, and comets, maintaining order and balance in the vast cosmos. Without it, Earth and other planets would drift lost in the endless universe, and life could never emerge. This invisible yet mighty influence highlights the sun's unique status and profound significance. Even more mysterious are the many unsolved puzzles within and around the sun, such as the corona's abnormally high temperatures, its complex and ever-changing magnetic fields, and the cyclical solar activities. These mysteries keep astronomers continuously exploring and studying. The sun is not only the source of our life, but also a beacon guiding scientists in their quest for cosmic truth.
Alright, that's all for today. If you also think the sun is amazing, don't forget to like, subscribe, hit the notification bell, and leave us a comment telling us which secret about the sun surprised you the most.
Next time, we'll take you on a journey to explore even more cosmic mysteries. Stay tuned.